Hello everyone and welcome to today's webinar, DevOps Enabling Low-Risk Releases. My name is Kate, I'm a member of the marketing team here at Pluralsight and I'm your host for today's session. I'm delighted to introduce Jeremy Morgan. Jeremy, thanks for your time today.
No problem.
Jeremy is a renowned Pluralsight author and he has over 15 years experience of working in engineering and leading DevOps teams. He'll be sharing his insights and wisdom with us today, wisdom that he's gained over the years on how to deploy releases faster and without them breaking so much too. But before I hand over to Jeremy, I'll run through some housekeeping. This webinar will take about 40 to 45 minutes and it is being recorded, and we'll send you a link to that recording in the next day or two. If you encounter any technical issues, please put a comment in the chat box and we'll help you resolve the issue. And this is your chance to ask Jeremy questions. And how you do that is simply click on the Q&A icon at the bottom of your screen and type them in as you think of them, and Jeremy will answer them during the session. So let's get started. Over to you, Jeremy.
All right, thank you. All right, thank you everybody for attending our webinar here on low-risk releases. My name is Jeremy Morgan. I'm a Pluralsight author and I've built 5 courses for Pluralsight in IT ops. I've been a developer professionally for about 15 years. And I've worked with a variety of companies, from startups that couldn't keep their lights on to Fortune 100 companies. And I've spent the last several years as a DevOps engineering consultant. And a lot of that has been in the Windows space. And now I'm a technical marketing manager here at Pluralsight. So today we're going to talk about ways that you can make your releases less scary, less painful, and most of all, less risky. Today we're going to talk about batch size and deployments, environments, the deployment itself, and optimized release structures. And then we'll open it up for some questions. So we'll get started. Now, this quote describes digital transformations perfectly. We need to slow things down in order to speed things up. Now, the idea is a little effort now for less effort later. And it's easy to get bogged down in the details and start to feel helpless when it comes to software releases. Like, I've been there many times. But if you keep your eye on the prize and put in some effort into your continuous delivery strategy, your future self will thank you. Now, we talk a lot these days about DevOps and blurring the line between developers and operations. Many operations have a stretch goal of it only being one single group. Like, there are no pure developers, no pure operations engineers, kind of everyone does everything. Now, I personally think that these two camps should always be separate, and there will always be silos in every organization, and sometimes that's okay. It's okay to have developers develop things and operations to keep it running. What we should strive for here is better cooperation and communication between these two groups. So if you have one person who can straddle between the two, that's great. And that person will likely be commanding deployment tasks. Deployment is the bridge between these two groups. It's kind of the proverbial wall that we've talked about over the years with DevOps. So we're focusing on deployment here because it's very important. Without this bridge, we have developers building things that never see the light of day and operations folks running machines with nothing on them. So it's important also because it's usually the biggest bottleneck in flow in an organization. Failures and inefficiencies here are felt everywhere throughout the organization. So we're going to focus on some ways to improve deployments. And we want to free up those bottlenecks and reduce risk in this crucial area. Now, many of you will remember we used to have pizza parties on Friday to do big software deployments, right? The big 1.0 to 2.0 deployment is here. Let's eat some pizza, pull the lever, and then spend the rest of the night and weekend mitigating problems. And if we're lucky, we'll come back to see the office, or we'll come back to the office frazzled Monday morning, version 2.0 will be up and working. And then we can start answering some of these support tickets that are coming in, right? So it wasn't much fun back then. Now, earlier in my career as a software developer, this was the norm, and this was very regular. And for some of you, it might still be. But there's a better way of doing things now that takes some adjustments. It takes a lot of tweaks and changes to the organization. You'll have to do things that are different than before, and some of them are downright counterintuitive. So I say no more pizzas for deployment, no more cakes celebrating the big release, because a deployment should be a non-event. It should be something that we don't worry about or really even think about anymore. Now, when I first started a job at a major tech company in 2008, it was about 6 months before any of my code saw the light of day. So the stuff I started working on my first day, 6 months later, it was out in production. So that was from the first day until the first release. And it was actually probably 6 to 9 months maybe. And it was a big release, and it was very painful to say the least. Now, by 2013, at that same company, I would write code and it would be tested and delivered in about 3 days. So we still did Friday deployments, but it was much easier to do at that point. And I was really impressed how quickly releases changed in these few years and how much faster they are now. So in order for deployments to be successful, they need 3 things. They need to be automated. You have to be able to automate anything you can. Now, this improves your speed of delivery, and it's, of course, far easier said than done, but you should automate every single thing possible. And it needs to be repeatable, and this is important for stability. You have to be able to repeat the process anytime you need to. Repeating the same deployment over and over should not change the state of the system. It should be idempotent. And it needs to be predictable. If your deployments are automated and repeatable, then they're inherently predictable. You should know what's going to happen every time you push the button. So how can we get there is what we're going to talk about today. So imagine you've been hired as an engineer at Globomantics. You'll be in charge of deployments and delivery of the company's software. Globomantics has had a system in place for delivering software for years, but they're in the middle of a digital transformation, like many organizations are today. Their competitors are putting pressure on them in the last few years to pump out features faster than ever. And naturally, Globomantics has to make some big changes to produce this software faster and get those features out the door faster, which is why you're here. Now, in order to deliver software faster, you can't have every deployment break or even several deployments break. You can't put your company at risk like that. So to understand how to make better deployments, we have to step back a little bit and look at the big picture. So deployments are a direct reflection of your batch size. A big deployment is a result of too much work being put into a single push. Altering our batch size can reduce the risk with our deployments. And let's look at our overall flow. Right? It starts with an idea, and this usually comes from our backlog or our ticket system. The idea can be, here's a new feature, or let's fix this bug, or something like that, but it starts with an idea. Now, once a developer has agreed to work on it, it goes into the development phase. And this is where the coding work is done. This is where the software is written, things are changed, refactoring, things like that. Once the developer completes the code, they push it into the testing phase. And then we have a set of unit tests, integration tests, things like that to make sure that the new code fits in and works with the system. After that's complete, it goes into staging. And this is where we can see how the code's really going to integrate with our system and try to catch regressions and things like that. Now, if everything is good and it's signed off, it goes into production. Hopefully our staging and production are configured identically so that nothing breaks here. And then finally, we have delivery. And this is when the customer actually starts to use the feature. In many workflows, pushing into production means it's delivered, but I'm intentionally keeping these separate here, and we'll talk about that later. And the big idea here is we want to look at the entire process and the speed at which it moves as a system. How long does it take to go from idea to delivery? Is it a month, a couple weeks, a few days? This is important. We want this to be as fast as possible. And bottlenecks in this process will slow down the overall flow. Where do we usually find bottlenecks? It's in the transition between these parts. Anytime the code moves from one stage to another, you have a potential for a bottleneck to occur. Now, the top things that create bottlenecks here are moving the code when it's a manual process or it requires human intervention or something like that, or if it's something that's really prone to breaking. Because if the flow is slowed at any of these points, the entire process is slowed. You may have people waiting on something to complete before they can move it forward, and all of that time is pure waste. So what's the first step in reducing these bottlenecks and increasing the flow? In my experience, the biggest and easiest thing to change is batch size. So let's look at a large batch size release. At Globomantics, we have a team that does a release at the end of each sprint. And we had to add in a database migration that our DBAs wanted. There was a schema change that needed to be made. And we made some additions to the UI during this time at the request of some customers who were dissatisfied with the current UI and layout. Also, some engineers noted performance problems with our API, so they did some behind-the-scenes refactoring to speed up queries. And we also had a business logic issue that affected a few customers, and we wanted to fix that also. Now, this is what a typical sprint could look like on any team, and we're really glad that we're getting so much done. We've got all of these things planned, and there's this big batch of cool stuff that's going to be deployed. But think about how many dependencies that we see here, and think about what the deployment portion will look like. When we push this all at once, one big push, we kind of hope for the best. What are some things that are likely to happen here? It looks like just my microphone here. Eric is saying the microphone's distorting. Is that a little bit better? Yeah, I can actually see if I can switch microphones here really quick.
Jeremy, it's Kate here. Yes, there is a bit of distortion to the sound.
Okay. Okay, I'll stop sharing really quick and change this.
Thanks, everybody. Jeremy's just going to sort out his microphone. He'll be back with us shortly.
Okay, is everyone able to hear me on this microphone?
Yes, that's clearer. Thank you, Jeremy.
It's clear? Okay, awesome.
No worries.
I have a backup microphone just for this purpose. Okay, there we go. Okay, so we have our big batch deployment here, right? So what are some of the things that are likely to happen, or what are some of the things that are likely to go wrong with this deployment? Now, as we try to push all of these changes through, we're taking a big risk because we've got a bunch of changes. They're all pretty big. What will it take to get them into delivery without any problems? So there are many things that can go wrong. For instance, the database migration can fail, the one there at the top. That can take out days to sort out and troubleshoot. And during this time, during this time, like the UI additions that we have here, the API, the business logic, all of those things have to wait while we figure out this database migration problem, for example. Or, any of these things can be interchanged. We can have problems with the UI and we're not able to make this whole release because we've got this huge batch of things that all have to be pushed at once. So everything else, if there's a problem with one of them, everything else just has to kind of sit and wait. And this is wasted time. This is kind of the equivalent of having items sit on a shelf at a grocery store and not move. These are features and fixes that you've already put money into and effort and engineer time, and it's all just sitting and waiting. And the engineers involved might be waiting too. So what's the overall cost to the organization? When you push deployments with large amounts of changes like this, you increase your chances of risk. The additions in the UI might change the behavior in kind of unexpected ways. The refactored API might break, or it might conflict with the database migration. And this is kind of like balancing your checkbook at the end of the month. You've got a whole bunch of items on there, and you just wait till the end of the month to fix it and make it better. Probably not the way most people balance checkbooks if they still balance checkbooks today. Now, if we break down each job individually and deploy that, it becomes much easier to manage. So let's take our database migration. How long will this take to push through? So now we have a smaller batch size of a single item. It's a single task with changes. And we'll know right away whether it works or if it breaks, and we can roll back and address the problem. So there's fewer regressions with just a single release. For instance, if we push a database migration all by itself and the service fails, we'll know immediately that it has something to do with that migration. So using the previous batch size examples, it could have been any of the other three things causing the problem. But now that we only have just this one thing going as a deployment, we have engineers spending time focusing on what they know is going to be the problem. And then it gets pushed through. Now this of course means you'll need to do more than one deploy per sprint, which is exactly the idea of weekly, daily, or even hourly deployments. This is how they came to be, and this is why folks started deploying things instead of doing like a deployment on Friday or a deployment at the end of the sprint or at the end of the month. That's why they decided we'll just do it today, you know, or tomorrow or something like that. This is the core of continuous deployment. Several small changes instead of a huge set of changes. And you need to look at branching as well with your source code. So as your developers have long-lived branches where they add feature after feature and tons of changes over a long period of time, this can cause problems, the same kind of problems as a big batch deploy. And as that branch is open, other developers are coming in and they're creating branches and merging as well. And if that developer doesn't pull in the changes frequently, when they go to merge that long branch, there's sure to be conflicts and problems present. You know, if you've got 4 different developers all putting their changes into this, and then we're going to try to merge it, you know, at the end of 3 weeks or something like that. So don't allow these long-lived branches to go through multiple features. Tie the branch to the task. One of the things that I found over the years early on was if you have a branch, it should be something like move the button to the left, or migrate the database, or migrate the accounts payable table, something very concrete and simple, and have that branch do one thing and one thing only. When you have a branch that has a whole bunch of different tasks on it, it kind of looks like that screen we had earlier where we've got a whole bunch of unrelated items all kind of going into the same batch. And at the end, when it comes time to merge and push this thing through, you end up with this big clogged mess. So how do we reduce our batch size? Now this one's cool because you don't need any fancy tools or anything like that. It's just human behavior. You need to break down the tasks and stories. So each of these should be refined to a point that it's as small as it can get. And this can be challenging when it's a bug fix that has multiple parts of an application or something like that, where you need to do a larger deployment. It can be tricky, but if possible, you want to break down the tasks to, you know, your tasks or stories should be just one single thing. And this one's a challenge. So if you have a feature you want to add, try to make it a single story or task and deploy just those changes and those changes only instead of the big long-lived branches. Not always possible to do, but it's something that you should always strive for. And then of course you want to prioritize these tasks. You know, after you break them down into small chunks and they're as small as they can possibly be, then you need to decide what's most important to tackle first, especially if you have 100 tickets all of a sudden. Because, you know, if everything is top priority, then nothing is top priority. Now, one way to prioritize your tasks is using a method that's found in the Safe Agile framework, and it's called weighted job shortest first. So it's like, what would you do? It's the cost of what would happen if you didn't do this task. It's cost of delay and job duration. So let's look at cost of delay first. We need to find out what the cost of delay will be. What would happen if we didn't do this task? What is the business value? Is this task something that will add features our customers will use? Is it fixing an issue that they have? Is it something that drastically improves the software? Or is it just kind of a little small change? And then how quickly does it need to be done? Is this something that needs to be done right this second, or can it wait? Does waiting to accomplish this cost us money or waste resources? And does this task reduce our risk in some way or open up an opportunity we would like? Does this bug fix add security to the application? Is it a feature that will enable better sales? You need to take all of these things into consideration when determining the value of the task. Using these metrics, some tasks will have more value than others. Some of them will be what we call the nice to have, and some of them will be critical based on these different characteristics. So you use this to determine what would the cost of delaying be? What would it cost us to not do this thing? And if we put it off for a sprint or two, how much are we losing? And then, of course, we want to look at the job duration. This is the estimate of the effort required to complete it. So this is what it will take in engineer time or cost or things like that. So the time to build is a big metric here. How long will it take to build this? Will it be days, weeks, months? You need to do your best to scope out and figure out how much time this is going to take. And then, of course, the resource needs. Can this be done by one engineer, or will it require a whole group of engineers? Are they going to be in the same group, or will there be engineers in multiple groups? And then you have to consider the change requirements. Will performing this task require changes from other groups, other parts of the business, or major changes in other parts of the software? And this is how you'll determine job duration. This is basically how long it will take. So to determine what to prioritize first, we have to look at the job duration versus the cost of delaying it. What tasks have a high cost of delay with the shortest amount of time to complete them? That's what you'll want to tackle first. You know, the things that if you don't do it, it's going to be super expensive and we can whip it out really quick, push that to the top of the list. And this is, of course, an oversimplified explanation of weighted job shortest first. And it doesn't apply everywhere. It's not a magic bullet, but it's a great way to prioritize these tickets, especially when you start getting tickets broken down into smaller sizes, and there's a bunch of them. So your first steps at Globomatics should be to work with your developers. Whether they're using Scrum or some other kind of management, you'll need to break down the tasks so that each task or story is a single definitive action. And then try to make that task deployable. Now, this is not always possible, but in the example that I provided earlier, we want to make the database migration is one task, and we're going to deploy that task. We'll just deploy that database migration, or we'll just deploy the UI changes. And then, of course, prioritize them so you can get the best efficiency right up front. And the next thing you need to look at before even addressing deployments is environments. And what I mean by that is this is where the software lives, whether it's a server, a container, application instance, means a lot of different things these days. It used to mean, you know, the big server in the data center. So we had a developer server, staging server, production server. Of course, we've moved away from that. So now this can cover, you know, a container, a Kubernetes cluster, an application in the cloud, just where the software lives in each of its stages. Now, in order for your environments to really work for you, they have to be set up properly, and this takes a lot of time. And it's not as easy as setting up a couple machines under a desk like we used to back in the old days, you know, and telling people, well, you can use my test server, just log in here, it's under my desk, things like that. These days, you need to be more deliberate and methodical in setting things up. They have to have consistent configurations, have self-service, meaning anybody who uses it can have access to change it, and it needs to be repeatable. And we're all pretty familiar with this setup for deployment. Right? Your developers build the software on their local machines or directly on the development server. Once they've deemed it ready, they push it to staging to be tested. And once it's tested, it gets pushed into production. So nothing new or mind-blowing here. But let's talk about some of the anti-patterns with this setup that I've seen in the past and that you've probably seen as well. And in this case, we'll assume this is a web server with the Globomatics website on it. Let's look at our production server. It's set up to run our software where our customers and users see it and interact with it. It's connected to a production database with real data. So it's configured a certain way to make each of those applications work. Now, the first anti-pattern here is Globomatics sometimes makes changes on production to fix things or add things without going through the SDLC process. You know, they make a config change, something like that, and just kind of change it on the server as we go, and then we'll document it later, maybe. Now, our staging server is mostly like production. It's configured similarly, and it's connected to a database that looks like production, but it doesn't have any real data in it. And that's not an anti-pattern, but that's how this is set up. And so there are a few config changes here and there, and the code is not exactly the same as it is in prod because we usually just manually copy artifacts and test our code that way. And then here's the Globomatics development server, which is nothing like production or staging, but it's a good place where you can toss some binaries on it and send it to someone else to look at. You can try to run some things and guess that it'll work before you push it forward. And most of the time, the developers don't use this server here at Global Mannix because it's not like production or staging. You might even hear some of the developers say, don't use dev for that or anything crucial, just push it into staging and we'll test it out. And this is exactly what I found very frequently in my years of consulting and in software engineering. This setup was usually the setup. It's super easy to fall into these habits when you're just trying to get the job done. You're trying to get things out the door. And this is something that probably resonates with you right now because we still have environments where development is pretty much a waste because it's nothing like any of the staging or production environments. So what makes this an anti-pattern? What are the problems? We have inconsistent configurations that are different on development, staging, and production. All of those small changes over the years have added up to where it's completely different configuration in the server. And we have manual processes. So most of the time the developers build the application, then they copy the binaries over as they go. And we have lots of isolated changes, meaning we change things on staging and production to make them work, and then we don't scale those changes back to dev or anything like that. So let's look at a little bit better setup. So a better setup would be something like this. We have our production server and its configuration is treated just like code. It's stored in the same place and it retains a state. We try to get this production server into a state. If you want to make a change to the configuration, you can't just log on to the production server and flip a few bits or change configurations. You have to submit a pull request to change anything on the server. And so right now you might be saying, well, if I want to produce software faster, now I have to go through a change board and approvals just to make a small change to the cache size of the server or something. And yes, you do. But this is not useless red tape because our staging server is configured exactly the same as production. We're using different certificates, we're using scrub data, different database, things like that, but the configuration itself is the same. It's from that same source system. All of the configuration of the server is basically treated like a piece of software. Anything that works on staging can be reliably expected to work in production because they're the same. And in fact, if we use the same set of binaries in staging as we do in production, if it works, then we know it works. If it breaks, our customers will never know it. So, if you build your binaries with debugging enabled in different spots, you can actually build the final binaries, throw them on staging, and it will run and go great, and then you can push it into production. Now here I'm introducing a dedicated testing server. This server is configured exactly the same as staging and production. And the server is just used for running unit tests, acceptance tests, integration tests, things like that. And this is the first stop for finding out how your changes affect the system. Here's something interesting about the testing server. It doesn't actually have to exist as a traditional server. Obviously, it's not going to be, a piece of bare metal sitting on a rack somewhere, but this is something that's very temporary, and it could be something the developer decides to spin up just for this project. So our developer can go in and he or she could say, I need a testing server that's just like staging and production, and they pull down a copy, and it's a small little mini replication of the staging and production server using that same configuration. They can run their tests and then just destroy it, and it's ready to go. And then we have the development server. Now this is configured the same as production also, and it can also be spun up as a VM. So it's kind of the same thing. For a development server, they take this small task and say, okay, it's time to spin up development. So we'll have a script. There's a myriad of different technologies out there, like Vagrant, things like that, where you can just spin up and create a server that's a development server that's exactly for developing things and then destroyed later. So our Global Mannix developer here is starting a new task, and she pulls down the source code from the repository and creates a branch. Now, as she's developing, she might push the artifacts to dev several times, or actually build it on dev just to see how it reacts. And this might be an environment where it runs locally, or maybe it doesn't run locally and it needs an actual server. But either way, we've got this on a dev server. And here we can either have her commit the code to the dev branch to be built, or just build the files locally and manually push them. And manual processes here are okay because it's going to match the cadence and the style of the developer. Some developers really enjoy building things on their laptop locally. But since we may need to debug these files, they'll be built with debug symbols and unminified, things like that. And these artifacts we don't use in production. So she does a spot check and just basically seeing if everything works fine. Once she's determined that the feature is ready to test, she commits the code to the repository, and then these artifacts can be tested. Now in the test environment, we have the same set of artifacts, but now they're going into testing. Here the developer can test and run automated tests and things like that. And you should have dedicated servers that this is the only thing that they do. This environment should be configured exactly like production. Any settings production needs to run should be set here. And in fact, you should be able to make a push button to create a test environment that's a replica of production. Making these VMs freely available is part of that autonomy that helps developers tremendously. Like if they're able to just spin up a test server by pushing a button, then it's far easier to do stuff like this. So as long as we have passing unit tests and integration tests, then everything's great and it can be moved to staging. Now, whether or not these artifacts are debug artifacts or not depends on your organization. You know, some teams like to run tests against production level artifacts. I've been on teams where they've kind of done it either way, where we've run tests against debug artifacts because we want all those debug symbols. And then I've worked at some organizations where they're like, no, this needs to be the exact binary that's going to be on our production. So this one's kind of a personal preference. So if all the tests pass, everything's great, then we're deeming it ready to pass to the next level, which ideally should be just a simple automated button push. Now our artifacts are in staging, and these artifacts should be built by a build server with no debug symbols or files. And if they're web files, they should be minified, things like that. These artifacts and files should be the exact same ones that we use in production, because this is the last place for a spot check. The staging server here is configured identically to production. So anything that runs, you know, any smoke tests, UI tests, integration tests, things like that should be run here, and we should be running it exactly as if it were sitting in production. And so if all the tests pass, everything's great, then we'll submit a pull request and we'll push it into production. So now the artifacts have been pushed in production, and hopefully it was an automated push, you know, it comes from source control, build server, things like that. And these are the exact same artifacts that we had in staging. And production and staging are configured identically. So we have no reason to believe that these are going to break for any reason. Now there are exceptions, of course, but following this deployment pattern makes deployment simple, easy, and predictable. All of your problems that are going to pop up should pop up somewhere in dev or test and be rectified. And then once those tests pass, you should be able to throw it on stage just for a quick spot check. Like, is this going to work in production? What's it going to look like? Is it going to break? And if everything's great, should be able to take those exact same artifacts or web files or whatever and just push them over to prod. So let's look at what we want from environments and see how this model works. We have consistent configurations because we're storing our configuration on the production server and we're treating that configuration as code. So we can do this with things like I mentioned, like Terraform, Chef, Puppet, SaltStack. There's a bunch of different software packages that can keep your configuration in a state. And in the cloud, there's things like CloudFormation, Azure Resource Manager, Google Cloud Deployment Manager, all of these things. That's their reason for existing, is the consistent configuration. And they should be self-service, because remember how I mentioned earlier, a developer can create her own environment, her own development environment, test environments, things like that. This is crucial, as if your developers can spin up a VM or an instance that's configured like prod with the push of a button, you enable this self-service that saves time for the developer and the operations staff. So it shouldn't be a long, drawn-out process like, can I please get access to this server, things like that. You know, instead of the sacred servers with names and things like that, developers should be able to just create an environment and then throw it away when they're done. It should be push button, give me a dev server, cool, this works, it's out. And finally, it should be repeatable. So if you follow the guidelines that we've talked about, this should all be repeatable. You should be able to create a server, run the artifacts, things like that, and repeat it over and over and over without changing the state of the server, anything like that. If you need to change some configuration to the server, that should go through a full pull request process, just like software. And this should be something that developers can do multiple times an hour even. They should be able to spin up a server, kick over their changes, things like that. So as long as your configurations are the same and the processes are automated, you shouldn't expect any kind of mistakes. So your next steps as the Global Manix Release Manager, you should be able to create configurations. And this is one of the most time-consuming parts of the process, is creating a configuration for your production servers. And this configuration is stored as source code. So anyone can take a new OS install and automatically configure a machine or instance like production. So if it's an actual server, they should be able to create a virtual server, run some scripts, or run Puppet or Chef or whatever you're using, and be able to create this server that's exactly like the production server, only of course smaller. You know, it's not going to have 64 gigs of RAM on it or things like that for development, but most of the configurations and the software configurations should all be stored. And you should automate everything you can. So if you create a build server to set it up to build artifacts when you check in code, things like that, it should be completely automated. And this is the best method to eliminate human error. So, you know, anything that's repeated over and over and over, smart people tend to kind of glaze over some of the details because they just really don't want to do this manual kind of process. So if you automate everything, make it a push of a button, gets rid of a lot of mistakes. And plus, if there are any tricks to make things work, it has to be included in the automation. So if we have to make this goofy change to the production server, that change has to be put into the automation in order to make everything work. And what that does is you'll have less tribal knowledge. You know, there won't be go contact this specific engineer because they know how to configure things to make things work for this. It'll all be stored in the automation. And allow your developers to create their own environments. So this can make security and operation folks kind of cringe when they're like, oh, are we going to let developers create their own server and create their own VMs and things like that? What if they're wasteful? What if they overdo the resources, things like that? This is one of those barriers that comes up. But it makes life easier on everyone involved if developers can just create their own environments and develop and test in those environments before pushing things out later. And to take that a step further, anyone should be able to, any developer should be able to build. So anyone on the team should be able to create artifacts from source control and deploy to any environment. And that's even production. And anyone should be able to run tests on their local machine or in a testing environment. They should have permissions for all of that. And anyone on the team should be able to deploy code anywhere. You should have enough testing and safeguards and automation and things in place that can prevent one person from taking down the entire production server. And it's a lot of effort to get there, but it's totally worth it. And this allows your teams to be as flexible and efficient as possible. So deployments, the deployment itself can be the scariest thing that any engineer does in their job. But it shouldn't be, right? It should be a non-event. And remember that some organizations deploy like multiple times an hour. It's said that Amazon deploys code every 11 seconds or so. Now, your organization probably doesn't need to deploy every 11 seconds, but you should adopt those same principles. Now, in the 2019 State of DevOps report, several companies were surveyed, and the companies that were considered low performers deployed between once a month and once every 6 months. Medium performers were between once a week and once a month. High performers are between once a day and once a week. And the elite companies are on demand, deploying multiple times per day. So it's pretty easy to say we need to deploy multiple times a day, but it's not really easy to make that happen, and it's not always necessary. Your deployment cadence entirely depends on the amount of features you're putting out and what works best for your company. So don't immediately think that you're a low performer if you only have once a month. You know, if you only have changes come out once a month because that's where your company deploys, that's fine. But this is just kind of an overall thing from the State of DevOps report where most companies are at. So how do we bring Globomanics to a high or elite level? Here's a few things that we need to expect from our deployments. We need packages suitable for deployment automatically built. So this means instead of pressing build in Visual Studio and then going to the folder and copying the files over to each server, we need to have an automated process that builds from source control. All the artifacts on your server that run your application should be built from source control. There shouldn't be any, you know, I'll build it on my machine and we'll push the binaries up, or I'll grab the dist folder off of my machine, and it shouldn't be any of that. It should all be built from source control. Things like file-based databases, cached files, user uploaded content, etc. All of those obviously aren't stored in your source control, but those should be moved in an automated process also. And it should be a self-service method. So you should have a push button automated way to deploy the code into production. And it's not merely for convenience. Mostly it's just to eliminate the risk of human error. Automated push button methods, they prevent tricks and tweaks and stuff from creeping into your process. And finally, all changes should be recorded. All the commands that were run and all of their results should be recorded into a log. And this is mostly for compliance and auditing, but it also helps you backtrack if you've had a problem. So if you've done the manual process thing over the years that so many people have done, you have to ask that person, ask that engineer, what did you do to deploy this and make it work? If it's all automated and it's logged, then we can say, okay, let's go back into the logs and let's see how this deployment went through. So let's take another look at our development environment. And we'll add in a couple of servers here. We'll add in a source control server and a continuous integration server. Now, ideally, this is the type of flow that we want to create for Globomanics. The developer pulls code from the source code repository and starts making changes. It can be pushed back and forth onto dev as we need to, as they're developing it. Again, that's one of the developer preferences. Maybe she wants to make a few changes, push it to dev, run it, test it, maybe do the development right on dev. Once the developer decides that it's ready to test, she commits it back into the source code server. The continuous integration server at this point picks up this change and builds a package for test and then deploys it. Automated tests are run by the CI server. So there's different unit tests, integration tests, things like that. And if they fail, the build is rejected and there we go. And then the developer is notified. Your build failed in our automated build environment. And then they can start the process over again. Now, if it passes, then a production-ready package is built and pushed to staging for another set of tests. And these can be demos, you know, actual human demos that you show other people, user acceptance tests, or other human-based kind of testing. So we've done a lot of the automated testing, and we know that's good, and now we need to get it in front of a human being to make sure that this is what we wanted and this works as we expected. Once that button is pushed, then at the CI server takes over, and it takes that same package, takes it from staging to production. And I have to stress that same package. So it's the same set of binaries or web files or whatever. The CI server should be pushing it from stage to production. And all of this can happen within an hour, possibly. So to get this done, you'll need to implement a continuous integration server. And that's something that's easy to say, but it's not cheap. So if your organization can't afford to build a set of CI servers, you can build in automation in-house. So your action items here are to take the system at Globomanics, automate the integration, automate the testing, and automate deployment. And again, this is for developers and operation folks to automate things. And this can be a big, fancy, complex automation system, or it can be a set of PowerShell scripts or Bash scripts. Just anything that automates things and makes it smoother to go through. So with this completed, we're now fulfilling the 5 steps to building a leading DevOps practice. To recap those steps, and I wrote an article about this on the Pluralsight blog that you can look up, and it's just 5 steps to building faster flow and a great DevOps practice. Step 1 is reducing your batch size, which we've done by breaking down our tasks, prioritizing them, getting them into smaller chunks, and then deciding what to deploy for each task. Step 2 is creating high fidelity environments, and these are the predictable, statically configured environments that we talked about that we've set up. Step 3 is to automate integration, deployment, testing, things like that we've done with our CI process. Now these steps are a lot of work, but it's well worth it to get features out to our customers, out the door fast in today's fast pace. And let's take a quick look at delivery, which can be entirely different from deployment. Deployment and delivery are 2 separate things. I mean, they should be 2 separate things. Depending on your organization's needs, you may want to decouple deployment and delivery. So when I talked about flow in the beginning, I intentionally put a delivery phase in after production. So just because you put something into production doesn't mean the customer can actually use it. While many organizations use the push to prod and make it live for everyone type of model, there are times when other patterns can be helpful. They're in like environment-based releases and application-based releases. So let's take something like a blue-green deployment pattern. Now here we have 2 different production environments, blue and green. We have our database, applications, websites, whatever, divided into these 2 environments. And both of them are configured exactly the same, hopefully with automation. And here we show the customers are going to the green environment. And this is our production environment. And this can be a set of servers, a set of services in the cloud, whatever. Now, as we build a new version of the software, we'll push it into the blue environment. Now this one is disconnected. And here we can test it, play around with it, make sure that everything will work properly. Once we're satisfied with that release that's in the blue environment, we just switch our traffic over to blue, which is now production. And we allow our users to use the new software and try it out. If it works, we'll leave it there and everything's fine, and we'll deploy the next release into the green. But if something fails or problems start, we can just flip the switch and go back to the green, which was the step back in production, and then work on that release in blue. And another variation of this is the Canary pattern. And this is named after the canaries that miners used to take into coal mines. You know, if the canary dies, there's not enough oxygen in there, et cetera. If there are deadly gases in there, it killed the canary. The idea here is to have your internal users see the new release first and have customers see the old version. So it looks something like this. And if your internal employees test it and everything seems good, you can point the general public to that same environment. And you can even partition your public users so that a small subset of your public users go to the new release and stay away. The rest kind of stay with the stable release. So in this instance, we're sending 5% of Globomatic's traffic to the new release just to see if it's good, see if there are any problems that come up, and then 95% of the users are still going to the stable one we had before. And you can gradually increase this over time until 100% of your traffic is going to that new environment with the new changes, or you can easily roll it back and then push everyone back to the stable one. Now, feature flags is another option. This is where you have the same environment and the same code deployed, but each feature is only flagged in the software itself for certain people. And again, we can have features that are turned on or off for internal employees first, but not the general public. And as we test the feature and find no problems, we can turn that feature on for a larger percentage of the visitors and eventually all of them. Now, this allows you to quickly roll back changes when things go wrong. Like, another great benefit is if your server or environment's under a high load, you can turn that feature off to kind of reduce the load and figure out why this new feature is slowing things down. So these are just a few patterns you can use to deliver your software after a successful deployment. And these patterns can be somewhat expensive and hard to set up, and they require good observability. You have to be able to observe into your system and know when things are working, not working. You need to know all of your load patterns, things like that, so that you can say, I'm going to push this new feature out, and oh, now I see that this is causing problems, we'll roll it back. Requires a good level of observability in the system. So your organization may not implement these patterns, but it's something to keep in mind if you're running very high traffic, busy applications. So here are your action items. You want to reduce your batch size, create high fidelity environments, and automate their creation. Enable self-service so that anyone can create environments and do deployments whenever they need to. Automate your testing, automate your deployment, and automate the integration. And then finally, determine what release looks like for you. Does release mean we push it to production, everybody uses it, jumps onto it? Does it mean we're going to use feature flags and distribute features? Does it mean we're going to do blue-green? All of those things, you know, one of those things you'll need to know as you're setting things up, and it's not for everyone, but there are different release strategies so that delivery looks a little bit different from deployment. So I would like to say thank you for all of you for attending this webcast and supporting us. And without eager technologists who want to learn more things, you know, we wouldn't be here as an organization. So thank you all for showing up and watching this. And I can open this up for questions if anyone has any questions.
Thank you, Jeremy, for going through all of that. That was really great. Some lots of really good hints and tips on how best for us to approach future releases. For all of you still with us on the webinar, and now's your chance to ask Jeremy a question. We're just about coming up to time, but if you want to type something quickly into the Q&A box, Jeremy would be happy to answer it.
And as a reminder, this is recorded, so if you're watching this as a recording, you can look me up on Pluralsight and send me an email or a message also, and I'd be glad to answer any questions that way also.
Exactly. Thanks for reminding me, Jeremy. It doesn't look like any questions are coming through. So, Jeremy, once again, thank you for your time today. That was great.
No
I'll draw the webinar to an end. As Jeremy said, if you think of any questions, please do reach out to him on Pluralsight and he will be happy to get back to you. So thank you for your time. Thank you for joining us today. Have a good day and keep safe.
Thank you.
Bye-bye.